This week we're going to finish chapter 6, so we're doing section 6.3, and then we'll go into chapter 7 next week, next class and the class after. So today is logarithms and applications. So for problem 1, we have to rewrite the given exponential function y equals a times b to the power t in terms of the natural base, that is in the form y equals a times e to the power kt. Round off k to 4 decimal places. So I believe last class we talked about, oops, mixing up my colors, hold on. Last class we talked about if we have y equals a times b to the power t, and we want to put it in the form y equals a times e to the power kt, we said that b is equal to e to the power kt. Okay, so we're going to use that fact here, and we're just doing the last class on Friday. We started in this form, in our natural log form, and we put it into standard form. Now we have to do the opposite. So it's in standard form, and we have to put it in natural log form. Using this, we can go ahead and solve for k. So what can we do to get k and t out of the exponent? Or really, we just have to get k out, sorry.
Could you repeat the question, please?
Yes. So what do we have to do for b equals e to the power k in order to get k out of this exponent? If it helps, look back to last class, those little like 5, or I think it was 5 rules that we had for properties of logarithms and natural logs.
Would it be the property where you multiply the exponent, so it'd be the 5th property?
Kind of, but so yeah, to get that k out of the exponent, we're really going to use the 5th property, but we also want to get rid of that e. I guess I should have asked that as well. So
Also,
we're just going to take the natural log of each side here. So if we take the natural log of each side, ln of b is equal to ln of e to the power k, then we have that k is just equal to natural log of b. So this is now our new fact that we're going to use to convert from standard to natural log form. So for problem part 1, we'll have y equals 208. Our initial condition stays the same. And then it'll be times e to the power of ln of 0.85t. And what's the natural log of 0.85t? Natural log of 0.85 is 208 times e to the power of negative 0.1625t. So that's your first answer there.
I have a question.
Yep.
I'm confused why you put the natural log of 0.85 times t as the exponent. Could you just walk through it again?
Yep. So we're going from this form here, y equals a times b to the power t, to y equals a times e to the power kt. So in order to do that, last class we took e to the power k and we figured out what that was, and we said that's equal to our b value. in this first equation. So when we solve for k, we got k equals natural log of b. So when I go to put it in this form, y equals a times e to the power of kt, a stays the same. We have e. My k is equal to ln b, and then we multiply that times t to get our variable in there. Does that make more sense?
Yeah, okay, thank you.
Yep. All right, problem 2. Here our initial condition is 1. So we have y equals, you don't have to write the 1, but 1 times e to the power of the natural log of b. Natural log of the natural log of 1.09 times t. So someone in your calculator, let me know what the natural log of 1.09 is.
.0861.
0.0861 times t. So this is the final answer there. Any questions on that one? Okay. Problem 3. We have y equals 700. Our initial condition stays the same. I multiply it by e and I raise it to the power of what?
The natural log of 1.32.
Good, times t. And what is the natural log of 1.32?
0.2776.
Good. Times t. So our new function, or rewriting the function in natural log form, is 700 times e to the power of 0.2776 to the power of t, or times t. Any questions on that one? Okay, problem 4. How do we rewrite this one? We have y equals what?
2000 times e to the natural log of 0.91 times t.
Good. And someone else plug that in your calculator and let me know what the natural log of 0.91 is.
Negative 0.0943.
Good. So the final answer is 2000 times e to the power of negative 0.0943 times t. Any questions on that first problem there? Okay. Problem 2. If a bank offers you an interest rate of 6.1% with interest compounded continuously rather than once a year, your balance B of t after t years is B of t equals B sub 0, which is just the initial condition, times e to the power of 0.061 t, where B0 is your initial deposit in dollars. Okay, so how long will it take for your money to double? So if we want to know how long it'll take for our money to double, we'll have B sub 0 times e to the power of 0.061 t. And I'm going to set that equal to 2 times B0, because we want to figure out, so we want to solve for t, and we want to know when we have double the initial condition. Does that make sense?
Yes.
Okay. So your first step here, if you divide both sides by b0, those divide out to 1. So you're left with e to the power of 0.061 t is equal to 2. How can I solve this for t?
Using the properties.
Good. So what's the first property I could use?
Is it the first one?
Yep, so we could take the natural log of both sides. Natural log of both sides. And so what happens is the natural log and the e end up canceling out. So whatever's in this exponent gets dropped down. So we have 0.061 times t is equal to natural log of 2. It's important in these problems to not don't evaluate any of the natural logs or logarithms or anything like that until the very last step. So now from here, divide both sides by 0.061. So t is equal to the natural log of 2 divided by 0.061, which is about equal to what? Someone plug that in their calculator and let me know what you get.
I got 11.363.
Perfect. It's about equal to 11.363 years. Okay. Problem B is asking us how long will it take for your money to triple? If I want to know how long it'll take for my money to triple, what do I set b sub 0 of times e to the power of 0.061 t equal to?
3 sub
3.
Yep, a few of you just said it correctly. Yep. 3 times b sub 0. And what happens in my first step when I solve for t?
When you divide by b sub 0, they cancel out.
Yep, they divide to 1. So then you're left with e to the power of 0.061 t equal to 3. What's my next step here?
Take the natural log of both sides.
Good, we'll take the natural log of both sides. So on the left-hand side, we're left with 0.061 t equals the natural log of 3. So then t is equal to, when you divide both sides by 0.061, you're left with t equals ln of 3 divided by 0.061. Okay. The natural log of 3 divided by 0.061 is about equal to 18.01 years. Any questions on this first page? Moving on then. Okay. Let C of T be the amount of caffeine that remains in a person's body T hours after finishing a cup of coffee. The amount of coffee absorbed from a cup of coffee is 96 milligrams. The continuous growth rate of the caffeine in the body is negative 13.86. Find the formula for C of T in terms of the natural base. So the natural base is y equals a times e to the power of k t. What is my a value?
96.
Good, 96 milligrams. And do we know what my K is? And if we do, what is it?
Is it the negative 13.86?
Yes, perfect. So this continuous word here, whenever you see this, you know that you have continuous growth rate really, but continuous is a key word to know that you have the K value. So K is equal to negative 0.1386. We just need it in decimal form. So the final answer is y equals 96 times e to the power of negative 0.1386 times t. Any questions there?
Can you go through that again? I'm sorry.
So we just had to put it in the form of, actually, this should be C of t, but okay. We had to write out this word problem in, we had to find a formula for C of t in the terms of the natural base. So we have exponential functions in a few different ways. We have the natural base, which is this way. We have the standard form, which is up here, or sorry, which is right here. And then we also have, not really a form, but we also have R, the rate of growth or decay. So K, this K value, is different than the R value that we were looking at before, because K is continuous growth rate. So we're not growing, it's not every month at the end of the month you have a certain percentage that increases on your interest or increases from your interest. It's continuously increasing. So at every, it's not at every time increment, it's just always increasing.
Okay, all right. Thank you.
Right. Yep. So then that becomes our K, and then we just plug everything else in. All right. Problem B. Find the half-life of caffeine in the body. Round off your answers to 2 decimal places. Include units with your answers. Okay, so similar to a double time, half-life is the amount of time that it takes for the initial value to be cut in half. So for half-life, we have that our function is 96 times e to the power of negative 0.1386t. And I'm going to set this equal to 96 times 1/2, because we want to know when we end up with 1/2 of the initial value. An important thing to know is the half time, the doubling time, the time it takes to triple, anything like that is the same no matter where you start on your function. So if you have your exponential function and say it looks like this, okay, the amount of time, so let's say this is, 16, say this is 8. The amount of time it takes to get from where it's 16 to 8 is the same as the amount of time where it takes, should be 4. Is the same amount of time that it would take to get from 8 to 4. So the half-life and the double time are always the same. So this chunk here and this chunk here are the same time. But we always use the initial condition because that's what's given to us in the problem. But if you're not given an initial condition, that's important to know. Okay, so when I go ahead and solve this equation over here, what's my first thing I'm going to do?
Divide by 96.
Good, and those divide out, and we're left with e to the power of negative 0.1386t equal to 1/2. Now, what do I do here to solve for t?
Take the natural log of each side.
Good, we'll go ahead and take the natural log of each side. We take the natural log of the left-hand side, oops, natural log here, and ln here. we're left with negative 0.1386 times t is equal to ln times 1/2, or of 1/2. Our last step here is to divide by negative 0.1386, divide by negative 0.1386. So we're left with t is equal to the natural log of 1/2, all of that divided by negative 0.1386. Someone want to do that and let me know what you get?
I got 5.001.
So about 5.001 hours for the caffeine to be, for you to have half the amount of caffeine that you did in the previous hour. All right.
I have a quick question.
Mhm.
So if I had just done the natural log of 2 divided by the decay constant, I would have gotten the same answer. So is that something that we could do rather than having to like write it all out or go through all the steps?
If you took the natural log of 2 and then divided it by the decay
the de-
value,
Yeah.
you should not get the same thing. Or actually, oh, I mean, yes, you would, but that would be the, well, let me see. Before I speak, let me see. So you actually get a negative value, unless we were supposed to get negative here. Nope. So you're actually going to get the wrong sign because, and if you think about it, say we're starting at 8 here, and you're finding the double time when you do that, and when you find the double time, it's going to be back in time, so it's going to be the negative value. So it's better just to know exactly how to choose what goes here, especially because sometimes it's not always half and 2. Like we did triple last time, and the next one we're going to do 30%. Does that make sense?
Yeah, that does. Thank you.
Yep. All right, problem C. How long will it take for C of t to be reduced to 30% of the initial amount? Does the answer depend on the initial amount? So we have 96 times e to the power of negative 0.1386 times t is equal to 96 times 0.3, right? 30% of 96 is what we're looking for. Okay. What's our first step here?
Divide by 96 on both sides.
Good, divide by 96 on both sides, so we're left with e to the power of negative 0.1386t is equal to 0.3. Okay. Now from here, what's the next step?
Divide by 0.1386.
Careful, there's one more step in between. We have
Take
to
the
get,
natural log of both
Oh,
sides.
natural log.
yeah, perfect. Take the natural log of both sides. And we're left with negative 0.1386t is equal to natural log of 0.3. Now we go ahead and divide by negative 0.1386. So t is equal to the natural log of 0.3 divided by negative 0.1386, which is about equal to what?
I got 8.6867.
Yep. Now, good. Now, does the answer depend on the initial value?
No.
Good. The answer does not depend. Wow, I don't know what just happened there.
Why wouldn't it depend on the initial value?
Good. The reason it doesn't depend on the initial value is because we're finding a percentage or we're finding 30% of 96. So this right-hand side is 96 times 0.3. But in all of these so far, our first step has been to divide by the initial value. And our initial value ends up dividing out to 1 on each side. So if the initial value was 300 here, or 396, that would have divided out to 1 too. Does that make sense?
Yeah, thank you.
So let's try problem D. And that just goes to show that the half time and the doubling time, it doesn't matter where on your graph you start to find your half time or doubling time. It's going to take the same amount of time for your quantity to double or be cut in half. That further explains that. Problem D. So this is here. How long will it take for C of t to be reduced to 10 milligrams? Does the answer depend on the initial amount? So in this case, we have 96 milligrams times e to the power of negative 0.1386 t. And we're setting that equal to what this time? Can anyone figure it out?
10.
10, good. So we want to know how long will it take for us to reach 10 milligrams? Okay, so what's our first step here?
Divide both sides by 96.
Good. So we'll have e to the power of negative 0.1386 t is equal to 10 divided by 96. Okay, leave that fraction as it is. It's not a nice number. Leave it as it is because we want to get the most exact answer. So we're going to have to work with fractions, but we're just going to leave it as it is and then we'll plug it all in the end. Okay, what's our next step here to solve for t?
Take the natural log.
Good. Take the natural log of both sides. And when you do that, you're left with negative 0.1386 t is equal to the natural log of, again, keep it as 10 over 96. Okay, now what's our next step and our last step?
Divide both sides by negative 0.1386.
Good. Divide both sides by negative 0.1386. Divide by negative 0.1386. So t is equal to the natural log of 10 divided by 96, all divided by negative 0.1386. Go ahead and plug that into your calculator and let me know what you get.
I got 16.3186.
Good. 3186 hours. Good. Now, does finding this value depend on the initial amount?
Yes.
Yes, it does. Good. So the answer depends on the initial amount. Any questions there? Okay, moving on. Last page. Problem 4. The initial value of an antique chair, T years after it was purchased for $7,000 increases by 15% per year. We've definitely done this problem before, at least the first part. Problem A, write a formula for V of T in the form V of T equals A times B to the power T. So what does my formula look, or what does my formula look like?
7,000 is A.
Good. And what is my B value?
Wouldn't it be 1 plus R?
Good. It's going to be 1 plus R. In my R is 0.15. That's here. See, per year, per whatever, means we have the R value. See how that's different than the K value before. Does everyone understand that?
Yes.
Good. Okay, so B is equal to 1.15. So we have 7,000 times 1.15 to the power T. Problem B, when will we reach $16,000? So we have 7,000 times 1.15 raised to the power T is equal to 16,000. Okay, what's my first step in solving this?
Divide both sides by 7,000.
Good, so we're left with 1.15 to the power T is equal to 16,000 divided by 7,000 is just going to be 16 divided by 7. We want to keep it as a fraction though, because that's not a nice number. Now what's my next step?
Take the log of both sides.
Good, and we go ahead and take that log, the natural log. Oh, sorry. We want the log. We take the log. So we're left with T times log of 1.15 is equal to log of 16 over 7. Okay, now from here, this is usually where students get confused, and you guys, I'm sure I'll get at least 3 or 4 emails from you guys on the homework of how you're supposed to do it from this step. Everything highlighted in green is just a number. We're just writing it in a form that's not a super long decimal, but it's just a number. So all you do is you go ahead and divide both sides by log of 1.15. So then T is equal to the log of 16 divided by 7 divided by the log of 1.15. Someone plug that into your calculator and let me know what you get.
I got 5.9149.
Perfect. Any questions there? Good. Problem 5. Use this information for the following examples. Acidity of a liquid depends on the hydrogen ion concentration in the liquid, denoted by H+, and measured in moles per liter. The pH is defined as pH is equal to negative log of H+. So for problem A, the pH of orange juice is 3. Find the hydrogen ion in orange juice. So when we set up our problem for A, we're going to have pH is equal to 3. So 3 equals negative log of H+. Okay. How do I solve for h plus? So this is actually one of the logarithm properties that we didn't really touch much on, or you have to use yet. So it's this one here. Right, and then the opposite would be, if you have natural log, this is what it would be. But, so if you raise your log of x to the power 10, or take 10 and raise it to the power of what you have for the log. So if we raise both sides of our problem here to 10, then we'll get rid of the log and we'll just be left with negative h. So we have raise everything to the power 10. So it's 10 to the power of negative log of h plus. So what ends up happening is we're left with 10 to the third is equal to negative h plus. Divide both sides by -1. So negative 1,000 is equal to h plus. Any questions there? And then this is moles per liter. Okay. Problem B. The hydrogen ion concentration H plus in tomato juice is 0.0001 moles per liter. Find the pH of tomato juice. So when we set this up, we're looking for the pH. So we have pH is equal to negative log of 0.01231. All you have to do for this one is plug it into your calculator and let me know what you get.
I got 4.
Perfect. And that makes sense because 4 is on our pH scale. So it's probably right. Any questions there? All right. If you have no questions, have a great rest of your day. Feel free to stay for questions if you have.